Hey stats class, in this video we're going to go over the process of setting up a hypothesis test. So I've got several questions right here at the beginning in this intro to hypothesis test section that just go over the setup of the null and the alternate hypothesis. Now remember, these are two statements that can't be simultaneously true, so there's some type of an opposite going on. Alright, if you read this sentence carefully, a psychologist claims that more than, if you read that right there, more than implies a direction. So when you see something that implies a greater than or less than, then that is the alternate hypothesis, the one with the 1 beside it. So more than 5.8% is going to be the one that we're after here. So that's going to be that one. Now, if you look at H1, H1 also has a greater than symbol, but it's underlined. Right? We want strictly greater than because it says more than. It doesn't say at least 58% or 5.8%. It says strictly more than. So that's the alternate hypothesis. The null needs to have some type of equality. So equals is okay here. Less than or equals would have been fine here too. But strictly the equality needs to be in the null. Okay, so it's okay sometimes to see a less than or equal to, greater than or equal to in the null hypothesis, but our author, this textbook, basically uses greater than, less than symbols in the alternate and strictly equal to in the null. Okay, but we need to have some type of equality in the null hypothesis. So that's going to be the one for our setup. That is the one that has the strictly greater than in the alternate hypothesis. All right, reading through this one, again, we got to get our parameter correct. We've got a mean, proportion, and a standard deviation. So you can see down here we have proportion, so it's going to be proportion right here. Alright, and it says use the parameter P. It tells us the true proportion of fireflies unable to produce light. Alright, it claims that fewer than 6 in 10,000. Once again, we have a direction implied. Fewer than. That's less than. That's the less than symbol. So of all of these I'm looking down through here, there's the one that has less than. This has a less than 2. That's less than or equal to. And the big problem is our null hypothesis doesn't have any kind of equality. So this is the one that we want. 16 10,000ths. Alright, so when we see a direction implied, that's the one that's going to be, that is telling you the alternate hypothesis, the H1. Alright, this one, it says the mean, claim is the mean body temperature is equal to. Right, this is the null hypothesis because it's talking about equality, is equal to. How is it denoted? Well, the big thing here is it's the mean body temperature. So we're going to have one of these that has mean in it, and you can see B and C have proportions, P. So it's got to be A or D, and again, the null hypothesis is where we'll have equality. So that's going to be option D for us on this one. All right, and then let's look at this last example of the setups. We know it's going to be mean because all our choices are mean, but look at the wording of the problem. They're supposed to maintain a true mean temperature. So if this was open-ended and it didn't give us the symbol right there, that's the wording that lets us know this is about a mean and not a proportion or a standard deviation. But look at this next sentence. The owner of the brewery does not agree and claims he can prove the true mean temperature is incorrect. So no direction is implied. He's not saying the mean temperature is higher than that. The mean temperature is lower than that. He's saying it's just not that. So he's not implying a direction. So there is no direction implied, no greater than, no less than. This is a not equal to. Okay, so you can see that this one, A and D, both have not equal to symbol. The problem is D is in the null hypothesis, and we got to have equality in the null hypothesis. All right, so the null hypothesis, remember, means and proportions. It's the two we're going to do in this chapter, and 8.1, or sorry, 8.2 and 8.3. We're going to do means and proportions, and with those parameters, they become the center of a bell curve. So we want equality in the null because that locks the center of the bell curve. All right, so we need to start the process by locking in the center, and we have to have that equality. That's why that not equal to is in the alternate hypothesis and the equality is in the null.